Okay, so you see them everywhere, right? Solar panels on rooftops, out in these huge fields. But have you ever stopped to think about how they actually work? I mean, how do they take plain old sunlight and turn it into the electricity that powers our world? It kind of feels like magic, but it's all about some really cool science. So let's get into it and break down exactly how it happens.
Yeah, that really is the big question, isn't it? How does this silent, solid thing on your roof capture something you can't even touch, light, and turn it into a powerful current? Well, that's exactly what we're going to figure out together.
All right, check this out. We're going to use this diagram as our roadmap. We're going to follow the journey of energy, all the way from the sun, through the panel, and right to this light bulb. The real secret? Well, it's hidden right here, deep inside the tiny, microscopic layers of a single solar cell.
So to get what's going on, you've got to think of a solar cell as a super special, high-tech sandwich. No, not made of bread, obviously. It's made of two different layers of a material you've for sure heard of, silicon.
Okay, so the top slice of our silicon sandwich, that's called N-type silicon. And the N here is easy to remember, it stands for negative. Scientists do this thing called doping it, which sounds complicated, but it just means they mix in some stuff that gives it a whole bunch of extra electrons. These little guys aren't attached to any one atom, so they're just kind of hanging out, ready to move at a moment's notice.
Then you've got the bottom layer. That's P-type silicon. And you guessed it, P stands for positive. Now this layer is doped differently. Instead of having too many electrons, it actually has holes. You can think of them like empty parking spots, just waiting for an electron to pull in and park. So let's put it side by side. The N-type on top is packed with extra electrons, and the P-type on the bottom is full of these empty holes. That's it. That's the key difference. This simple imbalance, well, that's what makes this whole thing work. And right in the middle, where these two layers meet, they create something incredibly important, the p-n junction. Honestly, this little boundary is the absolute heart of the solar cell. Think of it as the bouncer at a club or the traffic cop at a busy intersection, because this is where all the action is about to go down.
Okay, our stage is set. We've got our silicon sandwich, we've got our junction. Now we just need something to kick things off. We need a spark. And that spark comes from a tiny particle of light, traveling all the way from the sun. It's called a photon. So let's go back to our diagram. See these little guys? These are the photons, streaming from the sun and just slamming into the panel. Each and every one is a tiny packet of pure energy, and when it hits our silicon sandwich, it delivers a pretty powerful punch. And this moment right here, this is the magic. It's called the photovoltaic effect. It's this incredible chain reaction. A photon hits, transfers all its energy, and just like that, it knocks an electron completely free from its atom. And of course, when that electron pops out, it leaves behind an empty spot, another hole. And that's actually where the name comes from. You've got photo, which is Greek for light, because, a photon kicks it all off, and voltaic, which relates to voltage. So light creating voltage. This little dance, where light creates an electron-hole pair, that's the fundamental step for all solar power. It all starts right here.
All right, so we've got a free electron. Awesome. Now what? Because if we just leave it there, it's going to find the nearest hole, pop back in, and nothing happens. Game over. So we need to get all these newly freed electrons moving in the same direction. We need to build an electron highway.
And this is where our hero, that p-n junction, comes back into the story. That special boundary creates this built-in electric field. You can think of it like a one-way street, or even better, like a slide that only goes down.
So how does it work? Well, this electric field is like a bouncer. It grabs the freed electrons and shoves them over to the N-type side. And it pushes the holes over to the P-type side. It sorts them perfectly and makes sure they can't just get back together right away. This separation of charges, it is absolutely crucial. So, by piling up all those electrons on one side and all the empty holes on the other, the solar cell creates a difference in charge. And what's that? It's a voltage. The cell is now, for all intents and purposes, a battery. It's got a negative side and a positive side, and it's just sitting there, ready to go. Okay, let's recap real quick. We've gone from a single photon of light to a freed electron, to creating a voltage. That's some serious microscopic action. So now, let's zoom out and see how all of this actually powers our world.
Let's go back to our picture one more time. You see the wires connected to the cell? That's our highway. We've just given all those electrons that are piling up on the N-type side an escape route, a path to travel all the way around to the other side where those empty holes are waiting.
And that's basically it. That organized, massive flow of electrons zipping from the negative side through the circuit, doing some work, like lighting up a bulb, and then flowing back to the positive side to fill a hole, that is an electric current. That's electricity, plain and simple. So, let's just boil it all down. Sunlight shows up, it knocks electrons loose, the special junction inside the cell sorts those electrons in holes, that sorting creates a voltage, and once we connect a wire, that voltage drives a flow of electrons, and that flow is power. It's really that simple, and elegant, and incredibly powerful.
And just think about this for a second. What we just walked through, that isn't happening just once. It's happening billions and billions of times, every single second, in every single solar cell that's out in the sun. It's this silent, constant storm of energy being created right before our eyes. It really makes you wonder, doesn't it? What amazing things are we going to power with it next?